Here's another problem in the maximization and minimization section. This time it's a little bit more difficult because we have the product rule in the original function to take the derivative of. So we're looking to find the maximum and minimum values of 5x cubed e to the negative x from -1 to 6. So you'll see here what I did. Went ahead and took the derivative with the product rule. Derivative of 5x cubed, 15x squared, times the second e to the x, plus 5x cubed times the derivative of the second, the e to the negative x, remember, times the derivative of the exponent, -1. But now, that's not very useful if you don't factor it. So notice what I did here. I took the greatest common factor out of those two terms. I said, well, I can factor out a 5x squared and an e to the x. When I factor that out of the first term, all I'm left with is a 3. When I factor that out of the second term, I'm going to be left with the factor of -1 and one of the factors of x to make that 3 minus x in the remaining factor there. Now, the zero product property tells us that when we set that factored first derivative equal to 0, any one of the factors of that first derivative could equal 0. So in this case, 5x squared could equal 0 when x is 0. We know exponential functions cannot equal 0. All that tells us is that that factor will not lead to a critical point. And then 3 minus x, if I set that equal to 0, gives me the critical point of x equals 3. So I have my two critical points at 3 and at 0, and my interval here from -1 to 6. I take that down and plug it into my extreme value theorem. So I can say any extreme values of this curve on this interval have to be either at -1, 0, 3, or 6. At that point, I just evaluate into the original function. And this time, now while MyLab wants the exact answers, I felt like I needed to go into my calculator to see what these were to make sure which one was the maximum and which one was the minimum. So I did that here. -5e is approximately -13.591. Of course, the second one's not hard to do. 0 is 0. The third one, 135e to the -3, is approximately 6.721. And then 1080e to the -6 is approximately 2.677. So I could see that this value is going to yield the maximum. So we can say there is a maximum of 135e to the -3rd when x is 3. And then this one would give me my minimum. We can say there is a minimum of -5e when x is -1. Pretty good problem, guys.